Hello geeks and welcome to Geeks for Geeks. This is Sai Prakash here, and today we are solving a problem of day 26 of 30-day Geeks for Geeks coding challenge. And the problem statement is something like this. It is called as project manager, and an IT company is working on a large project. The project is broken up into n modules and distributed among different teams. The amount of time required to complete each module is given in array duration. Two modules can be processed simultaneously only if there is no dependency between them. And it is given that m modules have interdependencies, and as a project manager, compute the minimum time required to complete the project. And if you have someone with IT or CSE background, then you might have given a paper called as management science. Then there we have a similar concepts like where we have to find a minimum time for completing a project or critical path and something like that. So they can relate to this problem. And for all the others, let me just simplify the problem statement. So a project is broken into n different modules, so each is a complete different function, and some these functions, some of these modules are dependent on other module, and each module takes this certain amount of time. Given that we have all the requirements met, it is going to take this duration, that this number of months. And we are given dependencies here, so 5 and 2, 5 and 0, 4 and 0, and 1 and 2, 4, sorry, 2 and 3, and 3 and 1. That means that project 2 is dependent on 5, and 0 is also dependent on 5. That means only when the project 5 is completed, we can go ahead with project 2 and project 0, right? And the same thing here as well. And only when project 4 is completed, we can go ahead with 0 and 1. And if you observe that 0 has 2 incoming nodes, that is, it is being dependent on both 5 and 4. So only when these two projects are done, then we can move ahead with project 0. And we are given months of each project, that is the time duration, and we have to find out what is the minimum time required to complete the project. And the output is 8, and it is not that easy to know to understand how this output is 8. Let me just try and simplify this by showing this graph for you. So I have copied the graph here. So these are our projects, right? So projects are named as 0 to 5, and their durations are 1, 2, 3, and 4. Right, and if you observe here, 2, 0, and 1 are being locked by some other projects, but 5 and 4, they are independent projects, right? So they are not being dependent on some others, right? There are no incoming nodes to that, right? So 5 and 4 are independent projects, and they can be started without any hesitation. So since they are independent projects, this is how I'm going to solve this project, right? So initially 5 is requires 2 months of time and 4 requires 3 months of time, right? So since they are independent projects, I'm going to start them simultaneously. And I have called them as seconds, but you can they can take them as months, right? So they can be called as units. So forgive me for that. So 5 and 4 will go on for 2 months, right? So in the 2 months process, so 5 will be completed and 4 will be completed only 2 months, and it has 1 month of work remaining, right? So now in this stage, once 5 is completed, so the lock on 2 is being lifted, right? So 2 has met its requirements and 2 is ready to be solved, right? So hence we are again going to go ahead with the project 2, and again project 4 is has remaining a duration of 1 month. So we are going to start these two projects, and we are going to run them for 1 month, right? Once 1 month is done, then project 4 will be completed because it is met their 3 months duration, right? So it is starting from here and it is running till here. So 3 months duration is met. So project 4 is completed, this is completed, this is completed, and 2 has taken 1 month of duration out of its total 3 durations, right? And now so 0, there is no lock on 0, so 0 is free to start the execution. Now 0 and 2 are going to be simultaneously executed for 1 month of duration. Now 0 will be completed at this point, so these 3 have been done and dusted, and 2 has taken 2 months of execution, right? So 2 has started here, and it has taken 2 months of time. And now in order to go ahead with the 2, 3, and 1, we need 2 to be completed, right? So now we are going to complete the project 2 with 1 month of remaining time. We are going to assign it to 2, and once it is completed, we are going to assign 1 month of time to 3. And then once 3 is completed, the locks on 1 are lifted, so it is either depending on 4 and 3, right? So these 2 are completed. Now 1 is free to be executed, and it is going to take 2 months of time alone. And if we count all these, 2 plus 1, it is going to give us 8. So 8 months is minimum time is required in order to complete this project. And given that they all are being done based on their dependencies, right? And if you observe the second example, right? So second example is is a classical case of deadlock, right? So 0 is being dependent on 1, 1 is being dependent on 2, 2 is being dependent on 0, right? So in order to start any project, uh, we need all other projects to be completed, right? So this is a classical deadlock situation, because 0 is being waiting for 1, 1 is being waiting for 2, and 2 is waiting for 0, etc., right? And there are, to be to be simplified, that there are no independent projects here. So each project is dependent on one thing or the other. Hence, we cannot complete this project until and unless we resolve those issues. So we are going to return -1, right? So I hope this explanation was helpful, and I have seen people commenting on the support regarding how these answers are being written. Yeah, this problem is not difficult to understand. So I hope I made it clear by this explanation. And how are we going to solve this problem, right? So first of all, we are going to perform DFS, because any graph problems we have to know. Let's say if I am at 5, let's say 5 is an independent project, I'm going to start my project here, and I'm going to search all the dependent projects to that. So I'm going to create an data structure which is going to store a key value data kind of data structure, which is going to store a key, and it is going to store all the projects that are depending on that. And using that, I'm going to do a DFS, and I'm also going to check for cycles, right? So if there is any cycle, we have to return -1. So for that, there is a beautiful article on GeeksforGeeks. You can check that out. I will also link it in the description. And so this is what we are going to do for checking cycle, right? So cycle is nothing but, in a graph, if we have a back node from a node, so then we can call it as it has a cycle, right? So we are going to maintain a couple of arrays, so a visited array and all, and we are going to maintain a stack. And whenever we are going to visit a node, we are going to add them to a stack. And while we are traversing, and we are going to check whether if it is already visited and it is already present in a stack, that means we have a cycle, right? So using that, we are going to take care of cycle, and we are going to do the DFS, and we are going to try and calculate value answers at each point, and in the end we are going to return the maximum time that is required, so which is the minimum time for the completion of the project, right? So let me start by coding this problem. So I'm going to use the VS Code for that. So okay, let me just set up my VS Code, and I will see you once it is set up. Okay, I have set up my VS Code editor for this code, and so I have copied the function signature. So let me just show you that. So it is going to take a VP and duration array. So it's going to be the duration array of each project, and NNM. N is going to be number of projects, and M is going to be number of dependencies. So let's try and write this function. So as I've said, I'm going to try and find what are the independent projects in this graph. So I'm going to create an array. I'm going to call it as IND. It is going to store independent projects, and let me initialize with 0. So what I'm going to do is I'm going to iterate to all the nodes, and if I have found any dependencies, I'm going to add 1 to that. And in the end, if a particular node has 0, then I know that this particular graph has some independent projects, right? So, and as I've said, in order to perform the BFS and DFS, we need some global variables. So I'm going to just try and initialize them for now, but no, don't worry. I'm going to explain what they do in the end. So I need a visited array, and I also need a counted array. So I'm going to later count everything. So counted, and we're also going to need a stack for checking the cycles. So I'm going to get a stack, and I also going to need a I'm going to do this is what important here. So I'm going to create a data structure that is going to be a dictionary, and it is going to store key values, and the values are going to be an array of what are the elements that are being dependent on our key, right? For that, I'm going to use a default dictionary. So default dictionary is nothing but it is a dictionary, but they are we can initialize our initial values. So it by default handles the case where the entry is not present, right? So it is from collections module. So from collections import and default dict. So I'm going to use that to create our data structure. So I'm going to call it as depends on. So depends on is going to be my primary data structure for storing everything. So let's initialize that. So depends on is going to be a default dict, and instead of passing an integer, I want to pass each values as a empty list. So I have to initialize everything with an empty list. I'm going to use the lambda function to do that. So lambda, and yeah, so this will create an empty list for all the entries here. So let me just fill this depends on and also this independent arrays. So I'm going to loop for I in range of n, sorry m. So from all the dependencies, I'm going to take all those dependencies. So let's call it as x comma y, and x is going to be my first variable, that is vp. So vp of I and of 0, and comma vp of I and 1. So this is going to be like 0 and 1. So x is going to be 0 and y is going to be 1, and I have to make an entry into my dependent array. So depends on of x dot append. So it is going to be initialized with a list. So I'm going to append this to that. So append of 5, right? So and we also have to fill up our independent array. So ind of y initially is going to be 0. I'm going to add this to 1. And now let me just print this out for you, so you will understand what these JSX are doing. So depends on and comma ind. Okay, so I have also copied a sample case here for testing purposes. And now if I print this, so you can see that this is our dictionary, as I've said. So 5 is the key, and the so 2 and 0 are the nodes that are being dependent on 5. And so this is going to be our independent array. So 0 has two dependencies, and whereas 5 and 4, that is 5 and 4 are 0 and 0. So they are independent projects. So they are independent modules here, right? So since we have independent modules, we can go ahead with this project, and we can check later whether it is being feasible or not. But if any case our independent array does not have any 0, that is all the projects are dependent projects, then there is no go, right? We are going to initialize we are going to do the elimination condition there, and we are going to return -1 in that case. So we are going to let's comment this out, and I will do that. So before that, let me just it is giving me error, right? So I will initialize them. So visited is going to be what, -1 times n. The same thing for all. So counted is going to be -1 -1 times n, sorry, n. And what stack is going to be -1 times n. Don't worry about this, because these are not going to be used now. These are going to be used in BFS and while we're checking that cycles. So I'm just initializing them so that we can use it anytime. So that's why I've used it as a global variable. Now we are going to check whether it has a independent projects or not. So for that, let me create a flag. So flag is going to be a 0, and we are going to loop this for I in range of n. And if a particular project, that is if ind of a particular project is equal to 0, that means we have an independent project. So we can simply say flag is equal to 1, and we can continue. I think we can break here. So once we break, and here I'm going to check if a flag is 1 or not. So if not flag, that is if flag is equal to 0, then it is no go. It is a rejection case. So we are going to return -1. So this is what happens in the second case, right? So second case, there are no independent projects. So the flag will be 0 itself, and we are returning -1 for the project. So there is no going further here. Now so since we have everything done, now we can simply check for the cycles in all those projects, and let's try that. So I haven't initialized the check cycle function, but once this is completed, I'm going to do that. So let's loop through this for I in range of n. So when I'm trying to iterate through each nodes, I'm going to check if it is a dependent project or independent project. So if ind of I not equal to 0, then if it is not equal to 0, I'm going to simply continue out of this. And if that's not the case, I'm going to say it is visited is equal to 1. So 1 signifies that it is being visited. And if that's the case, and I'm going to say check for the cycle. So self dot, I'm going to call it as check cycle. Sorry, let's use camel case here. Check cycle. and I'm going to pass I here. So I is a node, and whatever it is being returning. So if it is returning as a true, that is, if it has a cycle, then again it is a rejection condition. So I'm going to return -1, right? So if control is just till this point, that is, it has satisfied the dependencies, and it has satisfied the cycles, then we are going to initialize with our answer. So answer is going to be 0. Now we are going to perform BFS on all the keys, and whatever answer that we are getting in the end, we are going to return that. So for I in range of n, so let's check. So if IND, that is, if it is independent projects, then we are going to start our BFS. So if IND of I is equal to 0, if it is an independent project, let's know computer answer is going to be maximum of our previous answer, and we'll call BFS on this. So BFS, let's call it as BFS itself, and it's going to take two arguments. So my node, and I'm going to also pass a duration array, so that I can know how much duration each project is taking. And when this is completed, in the end we have our answer. Yes, we haven't declared our functions, but let's do that after this. So return answer, right? Now we have two things to do. So that is, we have to know say how our BFS is going to work, and self.bfs, right? We have to know, declare how our BFS is being working, and we should also check how we should also check how we are checking the cycle. And as I've said, in Geeks for Geeks, there's a beautiful article for checking cycle. I have referred that itself, and based on that, we are going to do how the cycle is being working. So let's initialize these two functions. I'm going to initialize DFS first. Sorry, BFS, and let's call it as define, and so let's say DFS of self, and it's going to take I, it's going to take duration, and so I have called it as sorry, it has to be DFS, right? So we're going to search for each of these things, right? And we, sorry, I have no previously said, I think I have said BFS in multiple occasions, so it is going to be a DFS, and this is our function, and it is taking I and duration, right? And the duration, we need two global variables, that is which we have initialized here. So as I said, so they are going to be global of my depends on. So this is the main data structure, guys. So everything depends on this, and we also need counted. So counted, right? So now what are we going to do? So we are going to know do the DFS and get the answer for each node that we are starting. So let's say my answer is going to be 0 initially, and I'll simply loop for I in so in the nodes which we have called a DFS on. Let's say if I called it on 5, then I'm going to know do DFS on 2 and 0, right? So depends on of I is going to return me my array of 2 and 0, and now I'm going to know call answer on that. So I'm going to say answer is going to be a maximum of my current answer, and again call DFS on all the other nodes. So self dot DFS of it is going to take again what is my value. So I think so we have given I, right? So I can call it as j, and yeah, I can call it as j, and this is going to be again j, and again we are going to pass duration. Duration is going to be constant for all these cases, and once we have an answer, so I can simply update counted. So counted of I is going to be our answer. So that is answer plus its duration. So answer is going to be the project time for all its children node, and duration is going to be project time for itself. So duration of I. So this I is going to be what is being passed here, and j is going to be all its children, that is on which we are performing the DFS, right? And once we are here, we can simply return counted of I, and yeah, I think that's it. And we haven't declared our base cases, right? So So if our counted is being previously calculated, right? If it is already calculated, then we can return the calculated answer itself, because once it is been covered by other nodes, then we can return directly the answer. So if it is not -1, we're going to say counted of I. So this is going to be the base condition, and this is how our base DFS is going to work. And now the only thing that is left is we have to just do the check cycle, right? Okay, so define check cycle, and it is going to take self as a default argument, and we are going to check cycle on a particular node. So I'm going to take node as an input here, and as I said, in order to check cycle, we are going to maintain a stack and visited arrays. And when I'm trying to do check cycle on a particular node, I'm going to say that I'm going to add them to my stack, right? And when I'm traversing, right, so if it is all being visited previously and it is already present in the stack, this is because there is a cycle in that case. So in that case, it is going to be a rejection condition, and we're going to return true that yes, it has a cycle, right? So that is how we are going to check cycle. And as I said, there is an article on Geeks to explain exactly how to check a cycle algorithm. You can search, and the first link that will be popped in the Google will be the Geeks link, right? So we are going to use the two for global variables, that is going to be stack and global of visited. And once we have there, and we're going to say we're going to add the particular node to a stack. So stack of I is going to be 0, is going to be 1. So when I say stack, we are not creating a stack, so we are simply saying that our stack array is going to be as visited as, we are going to mark it as is 1. So if it is 1, we know that it is in the stack. If it is 0, it is not in the stack. And let's try and loop. So for I in depends on of I is being passed, right? So I, and so I want to check if it is being previously visited, or if visited of I, if it is equals to 1, that is visited and it is already in the stack. So if stack of I is also equal to 1, and in that case we know that it is due to us presence of a cycle, then we are going to return true, yes, we have a cycle. And if that's not the case, if it is not present, that is in the else condition, I think we don't need else here, we can simply continue out of this. In all the other cases, we're going to mark it as visited. So visited of I is going to be 1. I think we did the same mistake here. I should call it as J, and visited of J, and visited of J, and again, so visited of J is going to be 1. It is marked as visited. Now we're going to check on check cycle here. So if self dot check cycle on this, right? So on on J, then we're going to return true. So if a cycle is present, then we're going to return true. If that's not the case, we're going to remove that from our stack. So stack of I is going to be equal to 0, and in the end we're going to return false, right? So if our control leads to here, that we know that it is not being present in the stack, we're going to return false. And I think we haven't declared our base case, right? So base case would be directly check whether if it is already present in the stack. So if stack of I equal to 1, that is if it is previously present in the stack, then it is going to be rejection condition, so return true. So there is a cycle, so this is going to return if the cycle is not present or not, and we are returning false, and we are removing it from the stack. Looks good. Okay, I think we are good to go. Let's just run this for once and we'll see if it is working or not. So yeah, the output is 8. So I have also previously run this code once. So we are getting the expected output, and let me just copy everything and paste it into our VS Code. So I can comment this out, and let me just run the sample example here. Let me tell you, this is an excellent problem, right? So there are many things to check here, and yeah, and see if this particular problem has been asked in a particular interview or not. And I'm highly doubtful that if I can get this solution in like half an hour or so, right? So it is It is a tough problem, but it is an excellent problem. It covers some maximum concepts like BFS traversal and check cycling and backtracking usually. So yeah, the execution time is 0.43, and the time complexity is going to be big of n, right? So anytime that we are doing anything is right, so we are only traversing one time, and even the BFS is going to be traversed on the nodes. So yeah, n is not going to be exact. Theoretically it is going to be like 4 or 5 n, but that practically it is going to be called as a big of n, and the space is going to be n because we have used arrays like visited array, and we have also used depends on a dictionary and all. So this is an excellent problem, and I hope we get more problems to solve like this. And yeah, I haven't to solve the problem completely on my own. I had taken some help, right? But this is an excellent problem to solve, and I hope we have solved this problem as well. And thanks for watching. I hope this video was helpful. Please give a like and subscribe to Geeks for Geeks, and we'll see you in the next day. Thanks for watching.